Hi everyone, let's start with learning outcome number 2 of Module 6, where we will be covering the lymphatic vessels and compare these to the circulatory vessels. Therefore, unlike the blood vessels of the cardiovascular system, which form this complete circuit starting and ending at the heart, the lymphatic vessels, they will actually carry lymph only from the peripheral tissues to the venous system. And as with blood vessels, the lymphatic vessels, they do have different sizes, so they will range in from a small diameter, which are called the lymphatic capillaries, to large diameter, which will collect all the vessels and therefore the lymph that's circulating in these vessels, and these are going to be called the lymphatic ducts. Now notice how the capillaries, they will start on the periphery, as we can see from these images of the upper and lower limbs. And the lymphatic ducts, they will be located more centrally within the abdominal and the thoracic cavities, as we see here represented by the thoracic duct and the right lymphatic ducts. As we already talked about the lymphatic capillaries on the previous slide, we can say that the lymphatic network will begin with these blind-ended tubes that are called the lymphatic capillaries. They can also be called the terminal lymphatics, and these will form this complex network within the peripheral tissues. And lymphatic capillaries, they will differ from the vascular capillaries in several ways. So first, we can say that the lymphatic capillaries are going to be larger, not only in diameter, but also if we do a sectional view of these lymphatic capillaries, they will be larger. So this just means that they do have larger lumens. Therefore, the next characteristic is thinner walls. So this makes sense, right? So if they have thinner walls, they will have larger lumens. And the thinner walls are due because of these endothelial cells that lack a continuous basal lamina. So there's one less layer within the lymphatic capillaries. Next, we can say that the lymphatic capillaries, they typically have this flat or irregular outline, and this is also due to the lack of the basal lamina and the pressure within those capillaries, which is small or sometimes non-existent. Moving on, we can say that they have collagenous anchoring filaments that will extend from this incomplete basal lamina to the surrounding connective tissue, which will then help keep the passageway open when the interstitial pressures increase. Remember that the interstitial pressure will move the interstitial fluid back into the vascular capillaries. And when this happens, if you did not have this connective tissue, then there would be a possibility that the lymphatic vessels would collapse, right? Because you don't have a complete basal lamina. And like I said, the pressure inside of these lymphatic capillaries are very low or non-existent. Therefore, you need this extra support to maintain the form of the lymphatic vessels. And last, we have that the lymphatic vessels, they do have greater permeability because their endothelial cells, as we see here on this image, they actually overlap instead of being tightly bound to one another like we see in the blood vessels. Now, the lymphatic capillaries, they're present in most tissues, but they are especially numerous in the connective tissue deep to the skin and the mucous membranes, and in the mucosa and submucosa of the digestive tract. And lymphatic capillaries, they're going to be absent in the central nervous system and in a few other areas, which include the bone marrow, the cartilage, the epidermis, the orbit of the eye, and the inner ears. This region of endothelial cell overlap, it also acts as a one-way valve. So it creates this one-way valve that will permit the passage of the interstitial fluid into the lymphatic capillaries, but it will prevent this fluid from escaping. And the gaps between the endothelial cells of the lymphatic capillaries, they are so large that there is little in the interstitial fluid that cannot find its way into the lymphatic capillaries. These capillaries, they also absorb not only interstitial fluid and dissolve solutes, but any viruses or any other abnormal items, such as debris or even bacteria that are present in the damaged or infected tissues. And as a result of this, a lymphatic capillary will contain these chemical and physical evidence about the health of the surrounding tissues, because they're basically surveilling everything that's circulating throughout our body. Now, from the lymphatic capillaries, the lymph will flow into the lymphatic vessels that then lead toward the lymphatic trunks in the abdominal, pelvic, and thoracic cavities. And the larger lymphatics are very similar in size to the small veins. Therefore, it is safe to say that the larger lymphatics, like the veins, they have these internal valves. The valves are quite close together in the lymphatic vessels, and in each valve, the lymphatic vessel bulges noticeably, as we can see from this image. So all these little bulges over here, they're representing the lymphatic valves. Now, the pressure within the lymphatic system is so minimal and much lower than that of the venous system. Therefore, the valves prevent the backflow of lymph within the lymphatic vessels, especially those of the limbs, just like in the vascular tissue. Because the pressure is very low, then the large lymphatic vessels, they have these layers of smooth muscle in their walls, and the rhythmic contraction of these vessels will propel the lymph toward the lymphatic ducts, which are the last and biggest of the lymphatic vessels. And skeletal muscle contraction and respiratory movements together, they work to help move the lymph as well through the lymphatic vessels, which in the case of the skeletal muscles of the lower limbs, this is very similar to the venous return. Now, with each inhalation, the pressure decreases inside the thoracic cavity, and the lymph is pulled from smaller lymphatic vessels into the lymphatic ducts. Because if you can remember from the first slide of this learning outcome, I mentioned that the ducts are located in the abdominal and the thoracic cavity. So therefore, the breathing movement will accelerate the move of the lymph throughout those ducts. Now, if you have a lymphatic vessel that's either compressed or it's blocked, or even if the valves are damaged, then the lymph drainage will slow and maybe even stop in this affected area. And when fluid continues to leave the vascular capillaries in that region, but the lymphatic system is no longer able to remove it, then the interstitial fluid volume and the pressure will gradually increase in this area, because you're accumulating fluid as it cannot exit through the lymphatic vessels. And the affected tissue then becomes distended and even swollen. And this condition has a name. It's called lymphedema. So lymphatic vessels are typically found in close association with blood vessels so that they can exchange the fluid easily from one system to the other. Also remember that I said in the beginning of the cardiovascular system that the lymphatic system together with the cardiovascular system are part of the circulatory system. So everything that circulates in your body, like blood and lymph, will be part of the circulatory system, which is not an organ system, but that it's made up of two organ systems. With regards to the lymphatic vessels in general, we can say that we have two sets of those. We have what we call the superficial lymphatics and the deep lymphatics, but both will collect the lymph from the lymphatic capillaries. Superficial lymphatics are more numerous than superficial veins, and they anastomose freely, meaning that they merge to form new networks more freely. They do travel with the superficial veins And this is where we find these superficial lymphatics. So in the subcutaneous layer next to the skin, in the loose connective tissue of the mucous membranes that are lining the digestive, the respiratory, the urinary, and the reproductive tracts, in addition to some cavities that include the pleural, the pericardial, and the peritoneal cavities. Now, the deep lymphatics, they're going to be large lymphatic vessels that will run parallel to the deep arteries and veins. And remember that the deeper arteries and veins, they're also going to be bigger. So this makes sense that the deep lymphatics, they are larger than the superficial lymphatics. And these lymphatic vessels, they will collect the lymph from the skeletal muscles and other organs of the neck, the limbs, the trunk, as well as visceral organs in the thoracic and the abdominal pelvic cavities, which makes sense since these deeper, they're going to be located in these regions. Within the trunk, the superficial and the deep lymphatics, they will converge to form larger vessels that are called lymphatic trunks. And there are several examples of the trunks. They include lumbar trunks, intestinal trunks, subclavian trunks, jugular trunks, but I don't need you to know any of this. I just need you to know that these lymphatic trunks, they will in turn empty into two large collecting vessels, which are the right lymphatic duct and the thoracic duct. And these will then deliver the lymph directly onto the venous circulation. So let's see how this works. Notice how on this image I have delineated this area over here. So this area will collect all the lymph from the upper right side of the body, which will include the right side of the head, all the way down to the diaphragm on the right side. And they will empty this lymph directly onto the right lymphatic duct. Now all the rest will empty into the thoracic duct. So this means everything that's coming down below the diaphragm and the left side of the body, including the left side of the head. So the biggest duct is going to be the thoracic duct. We can say that the origin of the thoracic duct in most individuals is going to be located in this expanded sac-like chamber that's called the cisterna chyli. The cisternal chyli receives the lymph from the abdomen, from the pelvis, and from the lower limbs, and it will penetrate the diaphragm together with the aorta through what we call the aortic hiatus. So it runs parallel to the aorta. And after collecting the lymph from all these areas and passing through the aortic hiatus, the thoracic duct will empty into the left subclavian vein near the base of the left internal jugular vein, right over here. So the lymph collected from the left side of the head, the neck, and the thorax, as well as the lymph from the entire body inferior to the diaphragm, re-enters the venous system right in between the left subclavian vein and the left internal jugular vein. Now the right lymphatic duct will collect the lymph, like I said, from the right side of the body superior to the diaphragm, and this duct will empty into the venous system at or near the junction between the right internal jugular vein and the right subclavian vein. So this is how all the lymph that's collected from your extremities, starting with the lymphatic capillaries and ending in the lymphatic ducts, will re-enter the venous circulation. Now this image over here on the left shows a healthy heart, and the image on the right shows an unhealthy heart that is covered completely with fat. So how does the fat get to the heart? Well, basically we saw that the thoracic duct will empty right between the internal jugular vein and the subclavian vein on both sides, right? So through the right lymphatic duct on the right side and through the thoracic duct on the left side. And how does the fat get to the heart? Well, we have these lymphatic vessels within the small intestine that are called lacteals. So when you have a diet that's high in fat, there are certain particles of fat that are too big to be absorbed through the blood vessels of the microvilli that are present in the small intestine. So these large fats, remember that the lymphatic vessels, they have big spaces between them. Therefore, these large fat particles, they will be able to enter the lymphatic vessels that are present in the small intestine. And these vessels are called the lacteals. And lacteals reminds me of lactose, therefore reminds me of milk, and fat is white and milk is white, so that's why they're called the lacteals. And from the lacteals, the fat particles, they will travel through the capillaries, through the vessels, through the trunks, through the ducts, until they get released into the venous system right next to the heart. So where do you think that fat is going to be deposited? Right near the heart. So this is why it's important that you control the amount of fat that you eat, because if it's not able to be absorbed by the digestive system in the small intestine, it will travel through the lymphatic vessels, more specifically starting at the lacteals, and they will end up at your heart. So this is why you need to watch the amount of fat that you ingest.